In the spring and early summer of 1939, Germany sent shockwaves through the global aviation community. In the span of just 4 short weeks, the absolute world speed record was broken twice. It was broken by 2 completely different aircraft. It was an absolute field day for the German Ministry of Propaganda. Up until then, no country on Earth had managed to shatter its own record so quickly and so boldly. Interestingly enough, legendary aircraft designers Ernst Heinkel and Willy Messerschmitt were both gunning for this record. But they worked completely independently of one another. Neither had any idea the other was even working on it. Major General Ernst Udet was, of course, well aware that these high-speed aircraft were being built. But he felt that an open, fierce competition between the 2 giants wouldn't do the German aviation industry any good. On top of that, Udet knew better than anyone about the massive egos and mutual animosity between the 2 designers. So to avoid being accused of playing favorites, he decided to just step back. He kept both teams in the dark and let nature take its course. Their approaches to the design were completely different. While Heinkel chose to modify an existing fighter, Messerschmitt took a totally different route. Right from the start, he designed a purpose-built record setter. He had zero regard for its future practical or military use. As a result, Messerschmitt's creation was as compact as physically possible. It was an aerodynamically clean monoplane. It was basically built tightly around the massive Daimler-Benz DB601 engine and a single pilot in the cockpit. Messerschmitt had originally pitched this bold idea to the German Air Ministry back in 1937. They signed a contract to develop and build 3 experimental prototypes. But this came with one major condition. A fully functional combat fighter had to be developed in parallel based on this exact design. The new aircraft was designated the Me-209. Honestly, though, it had absolutely nothing in common with the legendary Bf-109, other than being a low-wing monoplane. This record-breaking airplane was noticeably smaller than its fighter sibling. It had a wingspan of 25 feet 7 inches and a fuselage length of 23 feet 9 inches. It had a wing area of 114 square feet and a takeoff weight of 5,555 pounds. The aircraft featured a solid, all-metal construction. The main landing gear retracted hydraulically, but the tailwheel was fixed in place. The oil cooler intake was positioned right behind the propeller spinner. But the most fascinating feature was its surface evaporative cooling system. It held 58 gallons of water in special tanks. This water was fed into the engine's cooling jackets, where it boiled into steam. The steam was then routed directly into the wings. Inside the wings, the steam cooled down, condensed back into water, and cycled right back to the engine. The first Me-209 prototype was completed in June 1938. After long and grueling ground tests on that evaporative cooling system, the airplane finally took to the skies in August. Test pilot Hermann Wurster was at the controls. By the way, just 9 months prior, Wurster was the guy who set the world speed record for land planes. He hit 377 miles per hour in a Bf-109. For its very first test flight, the new aircraft was loaded with just enough fuel and water for 15 minutes of flight time. The aircraft weighed 4,500 pounds for this run, and just to play it safe, they decided to leave the landing gear extended. And that's when the problem started. Right after liftoff, an engine overheat light came on. This forced Wurster to make an immediate emergency landing. He reported right away that the handling characteristics were absolutely terrible. But the design team actually took it in stride. After all, the airplane was built purely for speed. Still, nobody expected it to be quite this temperamental. Another test pilot, Fritz Wendel, later took over from Wurster. He bluntly described the aircraft as a vicious little beast and an absolute monster to fly. The first test reports read like a horror story for any pilot. The engine ran rough and constantly overheated. The cooling system just couldn't handle the load. The cockpit environment was so unbearable that the pilot had to breathe through an oxygen mask the entire time. It was impossible to retract the landing gear at speeds above 155 miles per hour. Worse yet, during hard maneuvering, the gear struts would literally drop out of the wheel wells. Hydraulic fluid would leak out, completely splattering the windshield. At high speeds, the slipstream would rip the fuel caps right off the tanks. The takeoff roll was exceptionally long. Getting airborne was a struggle, and cockpit visibility was an absolute disaster. In the climb, the aircraft was highly unstable. The rudder became completely unresponsive in turns. With the slightest pitch input, the airplane constantly wanted to nose over. And if the pilot tried to bank hard at full throttle, this metal monster would just snap roll right onto its back. Flying this aircraft was a serious handful. Control stick forces were insanely heavy. When airspeed dropped to around 100 to 105 miles per hour, the flight controls went virtually dead. Landing was a total roll of the dice, even in calm air. On touchdown, the aircraft would dart around unpredictably, and the second you got on the brakes, it would instantly ground loop or skid right off the runway. Engineers tried to iron out some of the minor bugs, but most of the major design flaws carried right over to the second Me-209 prototype. In February 1939, test pilot Hermann Wurster took it up for its maiden flight. 2 months later, Fritz Wendel took the controls. He was gearing up to set a world speed record in the third prototype. However, one of his test flights nearly ended in tragedy. While on approach into Augsburg, the engine suddenly quit. Wendel had already dropped the gear by that point, but the windmilling propeller created massive parasitic drag. Because of this, the aircraft's sink rate increased drastically. The pilot desperately pushed the nose down. He hoped to trade altitude for enough airspeed to clear the trees lining the highway. Unfortunately, he ran out of room. The airframe hit the ground hard and was completely totaled. But miraculously, Wendel walked away. But just 5 days later, designer Willy Messerschmitt got a nasty wake-up call. The competition hadn't been sitting idle. Pilot Hans Dieterle had just set a new absolute world speed record in the HE-100 prototype. He pushed it to 461 miles per hour. Messerschmitt originally planned to use the third airframe for his record attempt, but this unexpected rival forced a drastic and urgent change of plans. To snatch the title back as fast as possible, a highly modified DB601ARJ engine was rushed to Augsburg. It came straight from the Daimler-Benz plant. The team dropped it into the first and lightest Me-209 prototype. This power plant was an absolute monster for its time. Its standard max output was 1,550 horsepower. But thanks to a specialized methanol injection system, the pilot could push it to an incredible 2,300 horsepower for a 1-minute burst. The team waited a few days for perfect flying weather. Finally, on April 26, 1939, Fritz Wendel took to the skies to smash Dieterle's fresh record, and he nailed it. He edged out the previous record by 5 miles per hour. He clocked in at 469 miles per hour. Interestingly, purely from an aerodynamic standpoint, the Me-209 was actually inferior to the rival HE-100. But that heavily boosted DB601ARJ engine did its job. It cranked out an extra 500 horsepower during those few critical seconds of flight to ultimately clinch the victory. Just like all the high-profile aviation records of the Third Reich, the propaganda ministry jumped on this achievement right away. When the success was publicly announced, the official paperwork was sent off for approval to the FAZ. At this time, the aircraft was cleverly redesignated as the Bf-109R. This was done on purpose. They wanted to give the rest of the world a very specific impression. The goal was to make everyone believe the record was set by a standard production fighter that was already in service with the Luftwaffe. Aircraft designer Ernst Heinkel was absolutely furious. General Ernst Udet hadn't warned him about Messerschmitt's secret plans. He immediately ordered his HE-100 to be prepped for a new record attempt. He was hoping to hit 475 miles per hour under the exact same conditions. However, in July, Heinkel received a strict order from the High Command to stop any attempts to break the record. The official stance of the leadership was that the absolute speed record had to belong exclusively to the Bf-109. As Udet grandly claimed, no other combat aircraft will ever surpass its speed. Meanwhile, work on the project continued. The third Me-209 prototype was originally being prepped specifically for the record flight. It wasn't finished until late May 1939, but even before that, they managed to roll out the fourth prototype. They finally tried to develop this version into a fully fledged fighter. Its fuselage was almost identical to the record-breaking airplane. The only major difference was the tail section, which was enlarged to improve stability. They also added the ability to mount weapons. These included two MG-17 machine guns and a 20mm MG-FFM cannon. This cannon was mounted right between the cylinder banks, but the engineers had to redesign the wing entirely from scratch. The new all-metal wing featured a straight leading edge, automatic slats, and slotted flaps for better handling. Its span was increased to 30.5 feet. However, the total wing area stayed the same at around 118 square feet. At the same time, the designers managed to significantly reduce the aircraft's maximum takeoff weight. It now stood at roughly 4,800 pounds. For flight testing, this combat prototype of the Me-209 was fitted with a standard production DB601A engine. This engine featured a surface evaporative cooling system. In practice, however, this system turned out to be incredibly unreliable. After just 8 test flights, they scrapped it. They replaced it with conventional underwing radiators. When flights resumed, it became clear that the new radiators weren't up to the task either. On top of that, the airplane remained extremely difficult to handle both in the air and while taxiing on the ground. In 1940, the engineers made one last attempt to save the project. They increased the wingspan to 33 feet. They also enlarged the tail area and installed a bigger radiator. But the subsequent flight tests showed a disappointing result. There were absolutely no real improvements in flight performance. It might sound like a paradox, but with every new modification, the flight characteristics of the experimental Me-209 only got worse. What is more, the fighter was severely underpowered. In the summer of 1940, they tried to fix the situation. They swapped out the old engine for the new DB601N model. It produced 1,200 horsepower on takeoff. At altitudes over 16,400 feet, it could push a full 1,270 horsepower for up to 1 minute. As for firepower, the engineers planned to install 2 MG-17 machine guns in the fuselage. They also wanted one powerful 30mm Mk-108 cannon right between the cylinder banks. They planned to mount 2 more of these cannons in the wings. However, those dreams crashed into harsh reality. The aircraft's weight had already jumped to almost 6,170 pounds. So they had to completely abandon this heavy armament scheme. But the troubles didn't stop there. The engine just kept overheating. To fix the issue, the designers removed the underwing radiators. They swapped them for a single large belly radiator under the fuselage. The result, however, was an absolute disaster. This setup created so much aerodynamic drag. The fighter's speed and maneuverability dropped even lower than the older Bf-109E. After this fiasco, all further work on the aircraft was permanently shut down. Meanwhile, the realities of the air war were shifting. On both sides of the front lines, altitude was becoming increasingly critical for combat aircraft. Whoever held the high ground held the advantage. So in 1943, as a quick stopgap measure, designers proposed building a new fighter. It was based on the proven Bf-109F airframe. All their focus and effort went strictly into pushing the aircraft's ceiling as high as possible. To pull this off, engineers deliberately sacrificed its combat performance at low and medium altitudes. This kind of radical approach was absolutely vital. It was essential if the Luftwaffe's primary fighter, the Bf-109, was going to effectively take on the enemy over the Western Front. That is where the fiercest aerial battles were unfolding. They were taking place at altitudes ranging from 13,000 to 26,000 feet. Sometimes they had to push even higher. This was because heavy American bombers like the B-17 and B-24 were cruising toward their targets at well over 30,000 feet. The new project was designated the Bf-109H. It marked the first step in a program to develop a high-performance fighter. This phase was incredibly urgent. High Command demanded a rapid modernization of existing aircraft so they could be thrown straight into battle. Meanwhile, the second, broader phase of the program called for the development of an entirely new ultra-high altitude interceptor. This aircraft was expected to roll out by the end of 1944. The original concept for the Bf-109H essentially used the classic airframe of the Bf-109F, but it paired it with a high-altitude DB601 engine and noticeably longer wings. This stretched the wingspan to almost 40 feet. It seemed like they had found their solution. But then, the technical department suddenly dropped a new requirement. The aircraft's maximum ceiling had to be bumped up from roughly 43,000 to an impressive 49,000 feet. This forced the engineers right back to the drawing board to massively overhaul the entire project. At the same time, another ambitious aircraft was in the works at Messerschmitt. This was the Me-2092, which was eventually supposed to completely replace the standard Bf-109. In April 1943, designers suggested putting all their chips on this new model. They proposed a high-altitude fighter based on it, rather than the Bf-109H. The plan was to power this aircraft with either a specialized high-altitude DB628A engine or the more powerful DB603U. This engine was fitted with a TKL-15 turbocharger specifically to handle the thin air. Based on theoretical calculations, this new aircraft could reach an incredible altitude of over 57,000 feet. It sounded fantastic, but there was one major catch. It became obvious that this promising fighter wouldn't see mass production until the end of 1944 at the earliest. And the Luftwaffe needed high-altitude fighters yesterday. So High Command ordered the engineers at Messerschmitt to shelve these ambitions. They were told to go back to the simpler Bf-109H project, but to apply their latest developments to it. Specifically, they needed to integrate that same cutting-edge DB628 engine. To see how the new engine would actually perform in practice, engineers took the airframe of a Bf-109G5 and modified it to fit a mock-up of the future power plant. Once the ground tests wrapped up successfully, a real working DB628 engine was dropped into a different airframe, a Bf-109G3. Finally, in May 1943, this experimental testbed left the ground for the first time. Sitting at the controls was the renowned test pilot Fritz Wendel. Although the new DB628A engine was structurally very similar to its predecessors, it featured a two-stage supercharger and an intercooler system. As a result, the engine was noticeably larger and weighed about 375 pounds more. To accommodate this, the aircraft had to be fitted with a massive cowling and a propeller with extremely wide blades. The fighter's nose was stretched by 2.5 feet, which completely threw off its center of gravity. To keep the aircraft from becoming too nose-heavy, a large counterweight was built into the tail section. On the Bf-109H model, to maintain this balance, the wings were moved 10 inches forward, and the tail surfaces were significantly enlarged. After a quick series of initial test flights in Augsburg, the prototype was transferred to a classified Daimler-Benz testing facility. There, it went through 2 grueling flight test programs, each lasting 30 hours. It was during these flights that the aircraft truly proved its capabilities. It reached an impressive altitude of 50,800 feet. While Daimler-Benz engineers were putting the first prototype through its paces, development on the ground didn't stop for a second. Another DB628 engine was installed into a Bf-109G5 airframe. This airframe was also modified with an enlarged vertical stabilizer and special straight wing inserts. This updated high-altitude prototype successfully took to the skies in June 1943. At the same time, the factories were already gearing up. Several older Bf-109F4 airframes were actively being converted into the first pre-production batch of the brand new Bf-109H high-altitude fighters. To improve the aircraft's aerodynamics and overall performance, engineers didn't just add new straight sections to the wings. They also moved the landing gear struts further outboard. On top of this, the tail section received an extended horizontal stabilizer supported by extra struts. In almost every other way, the new high-altitude Bf-109 variants remained very similar to their predecessors. Under the cowling was the time-tested DB601 engine. This engine was also equipped with a special boost system to provide a sharp increase in power during combat. The armament on this aircraft was pretty standard. It featured a single 20mm cannon and 2 7.92mm machine guns. The primary mission for these aircraft was to research the aerodynamic challenges of flying at extremely high altitudes and to further refine the onboard equipment. For actual combat trials, a separate, upgraded version of the Bf-109 was prepared. This fighter featured a fully pressurized cockpit, absolutely critical for pilot survival at those altitudes, as well as a more powerful DB605 engine equipped with a power boost system. Engineers also made room for various reconnaissance cameras to photograph enemy positions from extreme altitudes. In early 1944, a few of these fighters were deployed to an airbase near Paris. They were tested there under real combat conditions. At first, their flight characteristics seemed promising. The aircraft was able to climb to an impressive altitude of over 47,500 feet. But soon enough, a fatal flaw revealed itself. When the fighter entered a steep dive and accelerated to 453 miles per hour, the wings would start vibrating uncontrollably. They experienced severe flutter. A series of incredibly dangerous dive tests was entrusted to the legendary test pilot Fritz Wendel. In April, during one of these flights, the aircraft reached nearly 500 miles per hour. The wings started shaking violently once again. The moment Wendell pulled back on the stick to pull out of the dive, the left outer wing section simply snapped off in midair. After a few more flights, the development program for the high-altitude BF-109 was shut down for good. The High Command ultimately gave preference to its main competitor. This was the TA-152 high-altitude fighter. Meanwhile, in January 1943, a major conference was held at the Air Ministry. Leadership was presented with the ambitious Me-109TL jet fighter project. It was supposed to be a sort of backup plan for the legendary Me-262. At that point, engineers had only managed to build and test 3 prototypes of the new jet. Designers wanted to save as much precious time as possible on development and getting it into production. So they decided to piece this alternative aircraft together almost like a giant model kit. They used parts from existing airframes. The main fuselage, along with the nose and tail sections, came from the Me-155 high-altitude fighter. The wings were borrowed from the Me-409 project, and the landing gear was pulled straight from the Me-309. All the firepower was concentrated in the nose of the aircraft. It consisted of 2 20mm cannons. Each had 120 rounds of ammunition. It also had 2 even more powerful 30mm heavy cannons. On paper, the specs for the Me-109TL looked even better than those of its famous sibling, the Me-262. Thanks to a narrower and more aerodynamic fuselage, its calculated top speed was supposed to hit an impressive 609 miles per hour. However, when engineers took a closer, more practical look at the project, they were in for a major disappointment. It quickly became clear that using so many components from completely different airframes would only complicate and critically delay the development of the fighter. Because of these engineering mismatches, the entire concept of a quick and cheap backup for the Me-262 was rendered entirely pointless. At the same time, another project, the Me-209, was hitting an absolute dead end. Attempts to turn it into a fully capable combat fighter had dragged on for 4 long years. Even so, the designers had absolutely nothing to show for it. Nobody even wanted to discuss a realistic timeline for its completion. Meanwhile, successful test flights of the Me-262 jet prototypes clearly demonstrated a completely new direction for aviation. Leading experts unanimously agreed that from that point on, all available manpower and funding needed to be focused exclusively on jet technology. This position was fully backed by the Luftwaffe High Command. So, in May 1943, the endless development of the piston-engine Me-209 was finally canceled. This cleared the way for a jet-powered future. But the designers in Augsburg still had to fulfill a government contract for a new mass-produced fighter. On top of that, competitors from Focke-Wulf were constantly nipping at their heels. They had just introduced their latest FW-190 and TA-152 projects. This forced Messerschmitt engineers to urgently kick off development of a significantly larger and heavily modernized version of the classic Bf-109. Nobody expected any practical results from the old Me-209 project anymore, so the technical department allowed them to transfer its designation to an entirely new aircraft. Under the initial plan, this new fighter was supposed to share up to 65% of its parts with the standard Bf-109. This would have massively simplified production. In official documentation, it received the designation Me-2092. The first concept for the Me-2092 fighter called for using wings from the older Bf-109 model. However, they needed some major rework to add a new internal wing structure and wheel wells. This was necessary to accommodate the inward retracting landing gear. They decided to replace the old DB605 engine with the significantly more powerful DB603. Instead of having several radiators under the wings, they mounted a single large annular radiator in the nose. The overall shape of the fuselage still resembled the classic Bf-109, but it had noticeably enlarged tail surfaces for better flight stability. Ultimately, it turned out that the updated Me-2092 had absolutely nothing in common with the pre-war speed record plane. That aircraft had once carried the same name. Despite this, they decided to keep the traditional numbering. The first assembled test prototype went down in history as the Me-209. The new landing gear system retracted inward toward the fuselage. It was first tested on one of the experimental prototypes of the famous Bf-109 fighter. But extensive wind tunnel testing quickly proved that keeping the old wing from the base model was just impractical. The engineers decided to design a completely new wing with a much thinner profile. Originally, the designers wanted to fit the powerful 30mm Mk-108 cannons. But because of the new sleek design, there just wasn't any internal space left for the ammunition. To solve this problem, they installed special fairings on the upper part of the wing. This engineering solution not only allowed them to mount the weapons, it also noticeably reduced the aerodynamic drag of the aircraft. On top of that, they planned to mount 13mm MG-131 machine guns in the fuselage. The idea was for the ammo boxes to become a load-bearing structural part of the airframe itself. But the aerodynamic tests delivered another unpleasant surprise. This armament configuration drastically increased drag, so the machine guns had to be moved closer to the center of the aircraft. They were placed right into the wing roots. This move inevitably shifted the center of gravity for the whole fighter. As a result, it forced the designers to move the landing gear struts almost 10 inches forward. Because of all these changes, the wing had to be heavily redesigned all over again. By that point, the gross takeoff weight of the fighter had climbed to a hefty 9,039 pounds. This forced the engineers to rethink the entire airframe design yet again. As a result, when the new experimental Me-209 took to the skies in November 1943, it had very little in common with its predecessor, the classic Bf-109. This updated aircraft was equipped with a DB603A engine producing 1,100 horsepower. It also featured a massive Messerschmitt propeller measuring over 11 feet in diameter. At this stage of testing, no armament had been installed on the aircraft yet. After the initial test flights and handling checks, the prototype was brought back to the hangar for major modifications. They installed a new, much more powerful DB603G engine. It produced 1,900 horsepower and was equipped with a special injection system. Test flights resumed shortly after. Along with the new engine, the aircraft also got a redesigned vertical stabilizer. It became significantly taller and took on a rectangular shape. Later on, they tried fitting another engine variant, the DB603B, onto the same airframe, but they never got to finish those tests. In early 1944, during a massive American bombing raid on the city of Augsburg, this unique prototype was completely destroyed. Meanwhile, the leadership at the technical department wanted to see if they could fit a Junkers engine, specifically the Jumo 213E, into the Me-209. Since this engine had a noticeably larger diameter, the engineers had to completely redesign the forward section of the fuselage. Despite the difficulties, all the necessary work was successfully wrapped up by late fall. And the following month, assembly began on the next prototype. This was the sixth Me-209 in the series. It was completed in April 1944. This version received the Junkers engine with a takeoff power of 1,750 horsepower. It also had a 10.5-foot diameter propeller. The new aircraft was also equipped with a power boost system. The oil tank held about 32 gallons, and the total fuel capacity was nearly 143 gallons. Thanks to the boost system at an altitude of 32,800 feet, the engine's output could surge from 1,275 up to 1,690 horsepower. This was achieved by injecting almost 20 pounds of a special chemical mixture per minute. This time, they didn't hold back on the armament. They mounted two 30mm Mk-108 cannons in the wings, with 70 rounds of ammo each. They also added two 20mm MG-151 cannons in the wing roots, holding 250 rounds per gun. For mass production, Messerschmitt pitched two main versions of this fighter to the Air Ministry. The first was the ME-209A1, powered by a DB603G series engine. The second was the ME-209A2 with a Jumo 213E engine. On top of that, a few extra variants were planned with different armament configurations. The standard version was slated to be armed with a central 30mm Mk-108 cannon with 65 rounds, or a 20mm MG-151 cannon with 115 rounds. In addition to that, the wing roots were supposed to house two 13mm MG-131 machine guns. Each of these had a 300-round capacity. Even though the flight tests for both prototypes were highly successful, all work on this project came to an abrupt halt in June 1944. The reason was simple and pragmatic. By that time, the German High Command had already made the final decision to mass-produce the brand-new Me-262 jet fighter. Compared to the jet, the piston-engine Me-209 was simply obsolete, and the need for it completely vanished. It is worth noting that while the last production model of a piston fighter from Messerschmitt was the Bf-109K, the engineers still managed to create a range of interesting experimental aircraft right up until the end of the war. One of them was the Bf-109L. In fact, this was a prototype for a specialized high-altitude fighter. It was based on the airframe of the already canceled Me-209 project. One of the earlier test airframes was transferred to another program. There, it continued flight testing under a completely different designation. However, even though the Air Ministry had officially canceled the order, the Messerschmitt Company decided to build one more experimental prototype as a private venture. To avoid drawing unwanted attention and keep the project under wraps, they gave it the cover designation Bf-109L. Back in 1943, the development of the new Me-209-2 fighter still had official backing. This aircraft was being designed as a potential successor to the legendary Bf-109. Around that same time, the technical department approached the Messerschmitt design team with a new task. They wanted to know if it was possible to create a special variant of this aircraft. It would be equipped with a powerful Jumo 213 engine and a Junkers propeller. The main idea was to combine the engine, the nose radiator, and the oil tank into a single, compact unit. This would make the fighter's production and field maintenance a whole lot easier. While design work for this version of the Me-209-2 was underway, engineers decided to run an experiment. They installed the exact same power plant on an existing Bf-109F fighter. The bulk of the design phase was finished by November 1943. The very next month, construction of a full-scale prototype began in Augsburg. Suddenly, the entire Me-209-2 development program was officially canceled. Despite this, the design team didn't give up. Work on the experimental aircraft continued in strict secrecy, at least from the leadership of the Reich Air Ministry. It was this unique aircraft, secretly completed in April 1944, that received the unofficial designation Bf-109L. Later, in July 1944, the team completed assembly of another fascinating variant. This was the Me-209H prototype. This aircraft boasted a significantly larger wingspan and a powerful DB603G engine. It was fitted with a massive four-blade wooden propeller measuring over 11 feet in diameter. To improve cooling, the radiators were repositioned along the leading edges of the inner wing. German designers intended this fighter to be an absolute nightmare for American B-17 flying fortresses. To achieve this, the aircraft was equipped with a truly devastating arsenal. It featured one powerful, engine-mounted Mk-108 cannon, two 13mm MG-131 machine guns, and four additional MG-151 wing cannons. With firepower like that, it would have posed a massive threat in the air. Today, historians can only speculate as to why the formidable Me-209H never entered serial production. Most likely, its actual flight performance simply didn't live up to the expectations on paper. In the end, military leadership placed their bets on its main competitor. This was the high-altitude TA-152H fighter from Focke-Wulf.